Assalamualaikum. So kita tunggu yang lain kejap. Assalamualaikum.
Waalaikumsalam.
So today our new topic, Swam intelligence. So under Swam intelligence we have particle swarm, and then ant colony, firefly optimization, and cuckoo search optimization. So that one under Swam intelligence. Swam intelligence is a general name, and under Swam intelligence we focus on four topic. Okay, under Swam intelligence we need to cover. So first, particle swarm. Second, ant colony optimization. Third, firefly optimization. And the last topic for the subject, cuckoo search optimization. That one we can put under one name. We call swarm intelligence. Swarm intelligence. Okay. The can we start now atau nak tunggu? Baru 60, 30 orang lagi tak ada ni. So introduction to swarm intelligence. Swarm intelligence system are typically made up of population of simple agent interacting locally with one another and with their environment. For example, bees, ant, apa lagi, particle, and so on lah. And then the agent follow very simple rule, and although there is no centralized control structure dictating how individual agents should behave, local interaction between such agents lead to the emergence of complex global behavior. So for each iteration, we have for every particle of every what we call individual particle lah, or individual ant, for example, or bees, or apa lagi, or firefly. Okay, so they have local what we call local value. Okay, local interaction. For example, local mean the quality of chromosome lah, the quality of agent, or the quality of ant, for example. So they have own value lah, own value or own quality. That one for local. But for global we compare. Okay, for that iteration, for example, iteration number 1. So we compare. For example, we have 100 N or 100 particle, for example. So maybe particle number 1, the quality of particle 1 maybe 12. Particle 2 maybe 14. Particle 3 maybe 50. So till 100 particle. So we compare the value, then the best value considered as a global value for that iteration. Clear? Like this. For example, we have I need to saya tak boleh nak tulis ni, kena buka dengan Microsoft Edge. Yep. Okay, nampak tak share screen?
Nampak.
Okay. For example, for every iteration, like this, every iteration, for example, we set 100 particle. 100 particle. Particle mean maybe ants or bees or firefly or anything lah. Okay. Then each particle ni after complete iteration, one iteration have own value. We call own quality of particle ni. So we call local search. And then for global search, because we have 100 value for each particle ni, each particle 100, so mean we have 100 value for that particle. So we select the best value based on 100 particle ni. So the best value we call global search lah. Okay, global behavior. And then and then a natural example of SI stand for what? SI Swam intelligence. Okay, Swam intelligence include ant colony, bird flocking, animal herding, bacterial growth, and fish schooling. This is the example of Swam intelligence. Okay, the definition of swarming. Okay, the definition mean aggregation of similar animal generally cruising in the same direction. For example, for termite, bird, bees, and so on. Why do animals swarm? To forage better, to migrate, to defense against predator. Okay, social insect have survived for millions of years. Swarming is powerful, mean swarm can achieve things that an individual cannot. Mean by grouping lah, not individual action. So must follow grouping. Okay, grouping natural grouping. Okay, this is the example of swarming, bird flocking, bees, termite, and fish schooling. Okay, these are the bees. Okay, bees. But for bees, we not for this case, for this subject, we not cover. We just cover ant colony and particle swarm, firefly and cuckoo. Cuckoo, bird cuckoo. Termite, okay, like this. Okay, and we cover next topic, ant colony. Okay, the definition of swarm intelligence: any attempt to design algorithm or distributed problem-solving devices inspired by collective behavior of social colony and other animal societies. Then for this, what we call this swarm intelligence can solve optimization problem. Another definition of swarm intelligence, property of system whereby the collective behavior of agent interacting locally with their environment cause coherent function global pattern to emerge. Okay, the application of swarm intelligence. Okay, for example, for movie, so we can use optimization for rendering. Okay, rendering picture or image and so on. For networking, routing using ACO route. Okay, networking. For robotic. Okay, for military, NASA and so on. So usually they will use swarm intelligence. Okay, now we proceed to particle swarm optimization. Okay, introduced by Kennedy and Eberhard in year 1990, mid 1990, mid 1995, and PSO is a stochastic approach which has been grouped under Swam intelligence. Okay. PSO can be used to solve continuous and discrete problem, and can also derive from concept of bird flocking of bird which fly everywhere to find food, and each bird illustrated by as a particle. Okay, particle. Okay, and each particle moves stochastically in such space for feasible solution. Each of particle has own velocity and position. What does it mean stochastically? Siapa tahu? Move stochastically. What does it mean?
Randomly.
Yeah, randomly. Okay, for the first iteration, random. But the second iteration must follow the global search. The global value, mean the best value of, for example, we have 100 bird. So the best value among 100 tu, okay, others must follow the what we call the best value tu. Nanti we discuss later in detail how we implement based on this situation, based on bird what we call situation lah, bird environment. Okay, how it work? Okay, PSO is initialized with group of random particle. That's what we call stochastic, and then search for optimal by updating generation. So every iteration we need to update. Okay, for example, we have 1,000 iterations, so we need to 1,000 updating the value for each generation. Okay, kalau 500, so 500 need to update. So every iteration, okay, so we need to update the new value. So we should create table. So based on that table, we need to update always. And then particle move through the solution space and are evaluated according to the same fitness criterion after each time step. And in every iteration, each particle is updated. Okay, so how to update it? So we discuss by example after this. I give you one example, and then based on that example, we try to calculate, okay, manually, first iteration, second iteration, and so on. Okay, so lagi senang faham lah by example after this. Okay, so before we proceed to example, we need to go through the what we call the theory first. Theory dulu. Okay, so how to represent, how to illustrate the particle. So this is bird, particle mean bird. So each bird have what we call local best. Okay, this is for individual has this value, this local best, and speed factor to the best global. So among that article, we need to decide, or we need to determine the best particle for the best global value. And then final speed and weight influence and speed factor. So we discuss every single criteria after this variable. Like this. Like this. So we have many bird here. Many bird 1, bird 2, bird 3. So each bird have P best. P best mean local best. P best. So among this bird, we have maybe this bird is the best quality lah, the best value. So we assign this one as a global best. So okay, this one as a global best. Others must follow this value nanti. Okay, the global best ni. So how it works? PSO can indicate the velocity and position of particle in multi-dimensional space. Multi-dimensional space means more than 3D lah, more than 3D. So maybe up, down, left side, left, right, and so on. Can go anywhere. By updating both velocity and position, a feasible solution can be achieved. And then the fitness value comprised of global G best and personal best. Global best, the best of the best of value, and the personal best, the individual value derived from the simulated behavior of group of particle. Okay, and then P best is solution offered by each of particle, while the G best, the best of solution obtained from all particle. From article we compare, then we determine the best among the ni lah particle tu, the best value. Okay, the algorithm. First, we need to set, okay, initialize number of particle, maybe 50 particle, 20 particle, up to you. And then we need to declare the what we call the parameter, okay, W, C1 and C2. This is the constant parameter. So we discuss also after this W, C1 and C2 ni. And then we for velocity minimum and maximum. Okay. And then dimension minimum and maximum, calculate P best value for each particle, calculate new velocity, calculate new position, calculate P best, calculate G best, until this is for one iteration. Okay. And then the next iteration we follow the same process. Okay. So how to explain in detail. So we using example after this. Okay. Any question? Any question that you want to ask? Ada?
So far tak ada lagi.
Tak ada, masih blur-blur, tak apa. I understand. Kurang dulu masa saya belajar for particle swarm, satu kali saya tengok apa benda ini saya tak faham langsung. Maksudnya saya nak understand the explanation about this ni algorithm ni, PSO, ACO and so on. So I ingat you all pun sure akan blur jugalah first time. So second time okay, third time more clear lah. Okay, then W, C1, C2 constant. W stand for initial weight. C1 and C2 for acceleration constant. So after this we have formula. We need to study the formula of particle swarm and the maximum and minimum velocity and dimension or position D1 and D2, maximum, minimum and minimum. D for dimension, position. Okay. This one you need to we need to follow this what we call this formula. Okay. So nak tak nak you kena hafal this formula. Okay. This one and this one is a constant. This is a global. This is the velocity for ID particle. Okay, for each particle. This is the location, the dimension. Okay, this one also what we call random function. Random function range between 0 to 1. It's also random, mean the system put randomly the value R1 and R2 range between 0 to 1. Okay, so this is the what we call we call the velocity updating, and we need to consider two things: velocity and position update. Okay, position update mean VID yang the new position. This is the old position plus VID new. So for XID ni, new position, we need to combine with old position plus velocity. Okay, velocity. So the parameter selection, inertial weight W, the function of W to put some balance to the particle movement in such space, particularly in global exploration and local exploration. So the value for W after they do many observation and experiment, the weight, the best between 0 to 1.2. Okay, the best. The value of W equal to 0.9 or till 1.2, maybe 0.95 or 1.0 and so on, but maximum 1.2. And then C1 and C2, CF. Usually for C1 and C2, we put equal to 2. Okay, we put equal to 2. C1 and C2 is a constant, and the function of C1 and C2 to make sure all particle are within the boundary of P base and G base position. Okay, so this formula you no need to think. You just kata apa? Follow the ni lah. You just take the value of C1 and C2 only. And then in addition, swarm size or population of particle. How many? So generally, the particle size or swarm size between 20 to 50. So we can try and error. Maybe 30 particle better than 20, or 40 better than 30. Try and error. Theoretically, with the increase of swarm size, obtaining a feasible solution might be faster, but processing time will be higher. This is not faster, longer. And processing time higher. Okay. However, the iteration number can be decreased. Can you relate between number 1 statement and number 2 statement? Boleh relate ke tak? Can you relate? Yes or no? Hello? Dengar ke tak?
Yes, Doctor. Yes, sir.
Yeah. And then parameter control, parameter selection, stopping condition. So how to decide the number of iteration? How to decide? Baru 60-30 orang hilang ni, macam mana ni? Macam mana dia nak follow the what we call PSO punya ni teori after this. And then the criteria based on for iteration, number of iteration, the maximum iteration number when an acceptable solution was found and no improvement is observed. No improvement is observed mean no improvement lah, the value of inner function just maximum value. So for number of iteration, the same value we get. The same value. So we can stop lah the number of iteration. Okay, parameter selection. The selection of parameter is problem dependent. Okay, based on the problem. So maybe problem A, the parameter 1, 2, 3, and problem B maybe one parameter, the best parameter or the best value or the best result using parameter 4, 5, 6. Depend on problem. And closely related to exploitation and exploration. Exploitation usually P-best local. And exploration, this is P-best local, explore. And then exploitation, global best. Mean for exploitation, we need to refine the value, the result or the output. But the local ni just not refine the value, but just the value is cost. Maksudnya bukan refine lagi lah, cost. And then exploitation and exploration of particle in the search region show the behavior of the particle. And to have the best position and the fast convergence, the movement of particle need to be controlled with the application of suitable parameter that have been applied for benchmark function of or similar problem. And then for PSO, we have many variant or many type: binary, discrete, parallel, hybrid, and etc. So for binary, we're using formula like this lah, binary. Okay, this binary 1010 lah. Okay, and then for discrete PSO, so the application that we can use for discrete PSO is evacuation. Okay, evacuation vehicle assignment problem. Okay. Okay, this example. This is the fitness function. This fitness function for this problem. Okay. So mean the evacuation vehicle problem ni, assignment problem. For example, for flood ni, flood problem, banjir. So how to assign, how to manage the vehicle punya vehicle to manage the movement of vehicle, for example. Okay, this is what we call number of people assigned and so on, the total number of boat, for example. Okay. So never mind, yani not so clear the explanation. I give you the clear explanation after this using PSO. Okay. For fitness calculation for that problem, the result like this. So you consider here we have population 10, 20, and 30. So the best based on this what we call research, or based on this experiment. So the best population, which one for DPSO? The best is DPSO lah. Particle swarm optimization, discrete particle swarm optimization compared to GA, compared to GA. Okay, that one for this topic, the most important thing that you should know this formula. Okay, this formula. We have two formula, updating value for position and velocity. Ingat kat sini, equation 2. So based on this formula, we try solve problem like this. Okay, I show you the problem. Sekejap. You can download dekat ni. You can download dekat mana? Dekat UFuture. PSO calculation. Tengok kat sini. PSO calculation. Okay, I give you I give you 3 minutes or 5 minutes to go through the explanation of particle ni, particle swarm, and then you need go through till problem kat sini, then we discuss the problem. So the theory part, okay, go through the ni, and then problem nanti we discuss how to apply the formula. Okay. So I give you 5 minutes or 10 minutes to go through. Boleh? Yes or no?
Boleh sir.
You download the article of PSO calculation. Then after that, we discuss the how to solve this problem using PSO. So this more clearer, more better to try to understand the PSO problem. PSO theory. Okay, 10 minutes or 5 minutes. Make sure you go through, jangan lupa. Download the article. Dah belum? Dah ke belum?
Belum.
Rồi, rồi.
Dah siap bagi tahu ah? Dah siap bagi tahu.
Dah, sir.
Ya, dah siap. Okay. Okay, consider the problem. Okay, this is the what we call the evaluation, the algorithm. Okay, consider the problem. Okay, the problem. This is our problem. Fx equal to minus x power 2 plus fx plus 20. Then range for x less than 10 and more than minus 10. So we have nine particle or 9 bird with initial position. So usually for every for first iteration, we put randomly for position. So we put randomly. So here we set the range of position between this range, minus 10 and 10. That's why x1 and x9 range between minus 10 and 10 by random. So how to find the maximum value for this function using particle swarm? Clear the question?
Yes, sir.
Clear kan? The question to find the maximum function for this function, the maximum value. Okay, then here we have 9 particle, and each particle have what we call position. The first iteration for starting, the position we put by random, and then the next iteration we cannot put random. We need follow the global best value after this. Okay, we have calculation lah nanti. I show you. Okay, then okay, the number of particle x1, x2 like this, and then the initial population for t equal to 0 can be represented as x0. 0 mean for initial iteration. I mean for ni lah, for 1, 2, 3 till 9 particle. Ni mean x for number of iteration, initial iteration 0 for ni, and then x1 mean particle number 1, particle number 2, particle number 3, particle number 4, and so on. Particle number 9, and then the location or position like this. So for each what we call particle, for each particle we need to calculate the fitness function. So the fitness function using this formula, this what we call the function. So f1 for particle 1 at iteration 1 iteration number 1, okay, initial iteration. After we substitute the value, so we can get the value like this. Boleh follow sekarang? Setakat ni?
Boleh, sir.
Boleh, sir.
Boleh kan? So f1, f2 based on this function, and then for constant, okay, ni variable ni c1 equal to c2 equal to 1, c1 equal to c2 equal to c1, and because of initial velocity, so v1 equal to 0 lah, sebab baru nak start kan, so no velocity for the initial step. Okay, for the initial population, so no velocity, so that's why equal to 0. So I nak you snap this what we call mana tadi? Sekejap. You snap the formula. Tak payah snap, ni dah ada formula ni. Okay, so we need to find step number 3, find the personal best for each particle. Okay, how to calculate the personal best? Okay, so personal best we can calculate by inilah personal best by our value ni kat sini tadi. The best, the maximum kan kita our ni our ni maximum value which one? F6 kan? This is the best. F6. So the best particle
F6.
Find the maximum P best is ni P6 2.3. Okay, 2.3. Ni kat tadi 2.3 ni. 2.3. Thus G best equal to 2.3 lah, because this the best among the particle ni. Clear setakat ni? Ni each particle have P best. P best. This P best. So among this article, the G best is the G best mean the best among this article. G best mean 2.3 lah. Because 2.3 is the best. Ni. The maximum value for iteration number 1. Clear?
Clear, sir.
Clear. Okay, so using the P and G ni, we substitute the value, okay, using this formula. R1 and R2 by random, range between 0 to 1. I explained just now tadi, the R1 and R2 range 0 to 1. So for this case, R1 equal to 0.213 and R2 0.876, and find the velocity. So we substitute, we replace the value C1 and C2 equal to 1. Vi, the velocity ni berapa? Because of T equal to 0 kan? So the velocity 0 plus this one we replace. So for V1 we can get this value. V2 for particle number 2, particle number 3 till particle number 9. Boleh? Boleh follow?
Boleh, sir. Boleh follow.
Boleh kan?
Boleh, sir.
So based on V, the velocity, so the next step we need to find the value of X. Equation number 2. The first one, equation number 1. Now using equation number 2, the position of the next position. So Xi, the next position, the new position, old position, and then this the velocity for the calculation. Just now we calculate. So the new position like this. Okay, new position. So the best, which one? This one kan? Sorry. Then based on this position, we using the finite function value, the formula fx equal to ni, fx equal to minus berapa? Ni yang ni. We replace ni minus x2 plus 5x tu minus plus ni. So we substitute x1, x2 and x3 ni, then we can get the f. So the best value, which one?
F7.
F7. Okay, this is best. No. Yeah, F7 the best. Okay, F7 the best. Mean for F1, F2 ni, this is P best for iteration 1. P best. So among this, what we call particle, the G best is G best equal to 26.231. So the G best ni, we bring to the next iteration, the value of G best ni. So we follow the same process till we reach our stopping criteria. Maybe we can set 100 iteration. So after 101, so the process will stop. So the process will continue lah, keep continue using F1, F2 and ni. Boleh faham?
Boleh, sir.
Sikit-sikit kan? Okay. I give you 10 minutes to go through the what we call the calculation Okay, the calculation sampai sini. Then kalau tak faham, then I explain again. And then the finally the value of x2 ni, iteration 3 or iteration 2. Iteration 2 mean we start x equal to 0 for initial iteration. X1 iteration 1, x2 iteration 2. This is initial iteration lah. So x3 mean x2 mean iteration 3 lah. After three iteration, the value ni did not converge, so we increase the iteration number as t equal to 4 and go step ni within the position, so on. So I nak you all go through, then tak faham, ask me which part you not so sure, so I explain again. Sekarang go through. Dah siap bagi tahu? Okay, dah siap?
Dah sah.
Yang lain? Ada soalan?
Saya kurang jelas sikit untuk step number 6 tu.
Step number 6. Jap. Okay, step number 6 macam ni. Step number 6. Okay, kita ada we should consider two formula kan. The first formula yang ni, this is equation number 1. Equation number 1. Ni equation number 1 ni. Equation number 1. Okay, so after we calculate, okay, after we substitute the value ni, P ni, we calculate P, so we substitute, so we can get the ni lah, the V ni. Yang ni faham kan? Step number 5.
Faham.
Okay, so based on what we call this value, we using equation number 2. Equation number 2 yang ni. Ni is equation number 2. Equation 2. Equation 2, based on this value, ni, based on this value, we substitute kat sini. Ni kat sini. Yang ni yang old value, yang lama. Yang ni yang baru, yang V. So the new position, so we based on combination between X and V, so we get this value. So based on this value, we using the function of ni, fx equal to minus x power of 2 ni, m plus ni. So we calculate, so we found that the value is the best f7. Faham ke?
Okay, so maksudnya yang X tu old value, lepas tu je substitute je lah. Okay.
So V ni, V daripada sini, X daripada yang the previous one, mana X? X kat sini, the previous one, campur dengan V yang ni. So kita akan dapat new X yang ni. So new X yang ni, we using this formula, fitness function. So from this formula, we have this value. So using the same process, maybe 100 or 20 ohm ni, then we can get the ni lah. The result getting better lah. So I nak you calculate. Okay, you calculate like this and plot the graph, number of iteration, the fitness function fx equal to minus x2 plus ni, or fitness function kat sini. Okay, so iteration number 1 mean iteration number 0 is iteration number 1. For this case, berapa ni? 26.7 kat sini. This is maybe 26. And then iteration number 2. After calculation, maybe the next point kat sini. Iteration number 3, the next point maybe kat sini. Iteration number 4 kat sini. Then you plot the graph, show me the graph. I nak you buat sampai 10 iteration. Boleh?
Sir, dia buat sampai 10 iteration ke sampai value dia dah jadi sama lah?
Kalau value sama takut you penat nak buat.
Oh.
So kalau tak dapat convergent value pun tak apalah, at least show me at iteration number 10 sampai 10. Kalau nak buat lagi takut you fed up lah. Kalau komputer tak apalah, you suruh komputer yang buat 1000 iteration pun tak apa, 1,000,000 pun tak apa. Tapi kalau you nak calculate, takut macam sekarang ni you just nak polish your skill aja supaya you have a skill how to calculate using particle swarm optimization to solve. Boleh? Faham ke? Macam apa nak kena buat lepas ni?
Faham sir.
Okay, sir.
Okay. So the next step, please do the please plot the graph for 10 iteration. And then next class, show me the result. I nak tengok graph. Macam mana you punya dapat. So sometimes because R, maybe your friend using R equal to R1 equal to 0.3 and R2 equal to 0.5. And then another friend maybe using R1 equal 0.2 because range between 0 and 1. So maybe the result is not equal lah. Dia punya ni. You jangan compare dengan your friend sebab different value for random ni R1 and R2 ni. So if random, so the value is also different lah. Tapi the graph show same pattern. Same pattern. Okay? Cuba you ni. You buat. Ada soalan? Tak ada. For particle swarm ada soalan ke? Tak. Kalau tak ada, I nak you ada? Tak.
Ada sir.
Kalau tak ada, continue untuk iteration 2, iteration 3, iteration 4 and so on. Then kalau tak ada, I stop kat sini today. So we continue after break. So after break, maybe we have one test, week 7. Week 7 or week 8 you prefer? Test. Thursday lah, Thursday.
Kita akan buat waktu lecture test tu sir.
Waktu lecture sebab semua group ada kat masa ni. Kalau waktu tutorial, I kena provide 3 set. Jadi penat lah nak buat 3 set question. So I need to, orang kata apa, same time lah. Same time for ni. Group A, B and C. Kalau tak, I kena buat 3 set. Penat lah nak kena buat. So terpaksa buat hari Khamis. Hari Khamis next week. Ataupun week 7 or week 8 you prefer?
8.
So week 8 we do the test. Okay, so see you after break. Assalamualaikum. Ya.
R untuk setiap iteration lain-lain ya?
Ya, lain-lain. Random.
Oh, tak boleh guna yang sama?
Boleh. Guna yang sama pun boleh sebab dia random.
Oh, okay. Thank you, sir.
Alright. Okay, bye. Assalamualaikum.
Thank you, sir.
Salam. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Salam. Thank you, sir.
Thank you, sir.
Jom.